Hey guys, this is a lesson on the Pythagorean theorem. Now before we get started on the actual theorem, we need a couple of definitions first. The Pythagorean theorem only works with right triangles. What makes a right triangle? A right triangle is formed with a right angle. So that little box over here in the corner, that represents a 90-degree angle, or that signifies a 90-degree angle. So thus, this is a right triangle. Now the two sides that make up the right triangle, namely this side over here and this side over here, those two sides are called the legs. Okay? And then that last side that's right across the 90-degree angle, this long one over here, that is going to be the longest side, and the word for that is the hypotenuse. Okay? So we need this distinction in order to actually apply the Pythagorean theorem. So the Pythagorean theorem states that given a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. What does that mean? So let's just give letters to these two legs. I'm going to call this leg A. So this leg is A. This leg I'm going to call leg B. And then the hypotenuse I'm going to call C. Okay? And the Pythagorean theorem is the sum of the squares of the legs, or A squared plus B squared, is equal to the square of the hypotenuse, equals C squared. Okay? So first thing you have to do is figure out what the legs are, or what two sides make up the right angle in the right triangle. Add the two squares up, and that should equal the square of the hypotenuse. So let's see this in action. All right, so we have a right triangle over here, and we have to find out what the value of the missing side is. So looking here, I can see that this side over here and this side over here make up the right angle in the right triangle. So those two are the legs. Now remember, it's the sum of the square of the legs equals the square of the hypotenuse. Now it doesn't matter which leg we call A and which leg we call B. I can call this one A and then B, or I can call this one B and A. It doesn't matter which one is A and which one's B. So I'm going to just say that this is A and this is B, and thus the question mark is going to be C, and we're going to need to solve for C. A squared plus B squared equals C squared. A is 3, so it's going to be 3 squared plus 4 squared is equal to C squared. Evaluate the two squares. We have 9 plus 16 equals C squared. 9 plus 16 is 25. And remember how to solve a square. You need to find the opposite of square is the square root. But because we're taking the square root of both sides, you have to remember the plus minus in front. So therefore, the value is going to be plus or minus the square root of 25, which is 5. Now, we're looking at the Pythagorean theorem. We're looking at a distance in this case. You know a distance is not going to be negative. Distances cannot be negative. It has to be positive. So therefore, C must equal 5. The missing side is 5 inches. Right? Now in this one, again, we have to identify what the legs are. We have this as a right angle, so therefore this is a leg and this is a leg. This time, in this problem, we have a missing leg as opposed to a missing hypotenuse. So let's figure out what A, B, and C are going to be. Like I said, the legs have to be A and B, but it doesn't matter which one's A and which one's B. So I'm just going to make the 10 equal A. The question mark is going to be what we're going to be looking for, and that's going to be side B. And then the hypotenuse is going to be 12. So A squared plus b squared equals c squared. A is 10, so it's going to be 10 squared plus b squared equals 12 squared. Evaluate the squares, and we're going to be left with 100 plus b squared equals 144. Our goal is to get b by itself, so subtract 100 from both sides. And we're left with b squared equals 44. And now we have to find the square root of both sides. Again, of course, we're going to need to write plus or minus. We're looking at distances, so the negative one does not make sense in this case, but we'll write it for good practice. The square root of 44 can be simplified to the square root of 4 and the square root of 11. The square root of 4 is 2, so therefore b is equal to plus or minus 2 square root 11. Okay, so therefore the missing side, like I said, negative sides don't make sense, is going to be 2 root 11 centimeters, which approximates to about 6 6/10 of a centimeter. Okay? All right, I want you to try using the Pythagorean Theorem on these two right triangles. Pause the video, see if you can do it by yourself, and then play the video to see if you are correct. Okay. Now I'm going to do this problem. I'm going to do number 1 first. Again, this is a right triangle, so we could use Pythagorean Theorem. A squared plus b squared equals c squared. We already have a and b identified for us. A and b are 10 and 24, and we have to find out what c is. We have to find the hypotenuse. So 10 squared plus 24 squared is equal to c squared. 10 squared is 100. 24 squared is 576. And the sum of those two together is 676 is equal to c squared. Last step is to find the square root of both sides. The square root of 676 is 26. Again, remember plus minus. So therefore the solution to this is c equals 26, because it can't be negative. The next one, a squared plus b squared equals c squared. This time one of the legs are missing, so we're just going to rewrite a squared and fill in everything else. Plus 12 squared is equal to 14 squared. 12 squared is 144. And 14 squared is 196. Solving for a squared, we have to subtract 144 to both sides. And you're left with a squared equals 52. Find the square root of both sides. And we're left with a is equal to square root of 52. You can break it up into square root of 4, square root of 13. Square root of 4 is 2, so it's a is equal to plus minus 2 root 13. So thus the answer to this is a is equal to 2 root 13, which approximates to 7 2/10. All right? So far we have that the Pythagorean theorem is that if we have a triangle, and it's a right triangle, then the sum of the square of the legs is equal to the hypotenuse. But also, we could use the converse of the theorem, or just saying the theorem backwards, to apply to certain problems. Meaning that if we're given that the sum of the two legs is equal to the sum of the square of the two legs is equal to the square of the third side, that means we have a right triangle. Okay, so let's look at an example of this. All right, so in this example, we have to determine whether the triangle is a right triangle given the lengths. So we have at 3 sides, A, B, and C. Now the hypotenuse is always going to be the biggest side. Okay, so even though they're labeling it A, B, and C for us now, the hypotenuse, or C, in our Pythagorean theorem equation will always be the biggest number. So here, A squared plus B squared equals C squared. We're going to need that 3 squared plus 5 squared needs to equal 7 squared. 3 squared is 9. 5 squared is 25. And that needs to equal 49. And if this statement is true, that means this is a right triangle. Now, 25 plus 9 is 34, which is not the same number as 49. So therefore, we can conclude that this is not a right triangle. Okay? So try B out yourself. Pause the video, see if you got this. All right? A squared plus B squared equals C squared. C is the biggest number, which is going to be 17, so A and B are going to be 15 and 8. So 15 squared plus 8 squared is equal to 17 squared. 15 squared is 225. 8 squared is 64. And it looks like times to the 12th power. 17 squared is 289. Okay? Now, 225 plus 64 is 289. So now we can see that this statement is true. Thus, this is a right triangle. All right. That's it. That's all I have. Have a good one, guys. Bye.